Welcome to part one of our Growatt installation series, where we're going to be installing the Growatt SYN microgrid interconnect device, a Growatt 11,400 watt inverter, and an LG Chem 16 kilowatt hour high voltage battery. This is a multi-part series. In today's episode, we're going to cover unboxing everything, mounting all the equipment on the wall, doing all the AC wiring, and there should be another 2 or 3 parts to follow up, which includes the DC wiring, the communications, the commissioning, and then just testing. Let's get into it. Alright, so I just hauled the battery down here on my little dolly. We're going to go ahead and open it up. Alright, so it looks like we've got 2 different battery modules down here. We got a battery control unit, and we got an unmarked box here with some yellow tape. So we're going to open this one first. Looks like it comes with some nice installation manuals and a template, some mounting brackets, some hardware, nice stainless steel. It's like some more mounting brackets. That might be a floor mount bracket there, I'm not sure. Some more brackets. It's like some strain relief fittings, watertight. Some nice long screws here, or bolts. It's like some fancy zip ties, and a couple knockout plugs, weather tight. Not much to see here, it's just one unit. Looks like it goes on the top of the batteries. So these are the battery modules themselves. It is a little bit hefty. I could probably manage it by myself, but what I'm gonna do is I'm gonna put the lid back on here and use the old dolly to get it into the house to make sure I don't either throw my back out or damage the battery. Alright, so here's the Growatt SYN, I believe they call it. Maybe it's just abbreviated, the SYN200. Looks like it comes with some hardware, some terminal adapters or little terminal plugs. We've got the quick start guide here, mounting bracket. Here's the unit itself. It's got a little disconnect from the service. Built-in 200 amp. Got a bunch of knockouts on the bottom. That's nice that they just kind of pre-drilled and you just have to remove the plugs. Alright, so the battery comes with this nice template, and that is going to make sure you land that BMS module bracket at the right height. So I'm going to go ahead and tape this to the wall. Looks like we want roughly 12 inches of clearance on every side of the battery. So I'm just going to pull it 12 inches off the wall. Alright, you'll see they have this little cardboard spacer, and that gets you to put this bracket spaced off of the wall just right. You'll also see there's rear and front etched into the metal, so just make sure you don't get that mixed up. Looking at it, I don't see a major difference between the two, but obviously there's a reason for it. Always be careful with tap cons. They're real easy to blow out, so you just want to make sure you don't ream the hole out when you're drilling it. And then also when you snug these on, you just want to snug them in. You don't want to really crank them down tight. And being ever so delicate here, this one ended up being a spinner. So we're going to use the old zip tie trick. Stuff a zip tie in there. Land it back in. And that sucker's tight. Next, we have these battery module support brackets and 12 screws. This is going to lock the two batteries together to the bottom plate there. All right, so next we're going to remove all this wrapping around the connectors on the battery module. Now we're going to remove these labels where those battery module connectors plug into. So next we're going to plug these connectors in. It's time to be careful that you hear an audible click. Which it clicked, and then after it clicks you want to push that red connector in to sort of lock it in place. Seeing the red connector on this one. Alright, so we're all locked in. Red tabs are nice and depressed. I think we're good to go here. I did hear an audible click on this one over here. Alright, so now it's saying to test the battery itself before connecting. So first you pull this handle open, you turn it counterclockwise, open the front cover. It says if there are no problems with the assembly, the LED power indicator will turn on. 60 seconds later, the LED fault indicator will blink due to lack of communication with the inverter, not due to a defect. Once we confirm that, we are going to turn the circuit breaker back off, close the cover, turn the handle back the way it was, and go ahead and start removing these spacers and connecting the BMS to the batteries themselves. Alright, and there's that blinking fault light it was referring to, so it looks like we're all good here. We're going to go ahead and turn off the circuit breaker, get this thing closed up, and remove the spacers. Looks like all those switches are actually connected together, so they're just one single switch, even though there's 3 different circuit breakers in there. This would be easier with 2 people, but that's just not how we're doing it today. So sometimes you just gotta improvise. Alright, so now we're gonna loosen the top 4 bolts here for the top of the BMS. Alright, so I think I made a mistake here with the spacer. Being that this says top, I used it when I spaced this sucker off the wall. I had that facing up. I think top only refers to when you're kind of putting the battery management system in place. Going back and looking at the instructions, I think we wanted to keep it turned like so, not like so. So looks like I'm, you know, a solid 1/2 inch off of where I should be. I'm going to go ahead and scoot this battery back a little bit. All right, so next we're going to take these long bolts here and we're going to drop them down through these brackets and tighten the BMS to the battery modules themselves. Next, we're going to connect this plate on the back. Somehow this doesn't seem to line up just right. I'm not sure why or if that's intentional. Doesn't seem like it. And I've loosened these screws and brought the bracket up about as high as I can get it. So for any of those people out here watching this video right now, make sure your bracket's going to line up before you get too far ahead of yourself. Anybody that doesn't have one of these little stubby ratcheting wrenches, they are worth their weight in gold when you actually need them. Okay, so here's our Growatt 11,400 watt inverter. Looks like we've got a mounting bracket right here on the top. Instruction manual including a sticker letting you know if you integrate Tigos with this system, it is rapid shutdown compliant in the US. Again, without integrating those Tigos, it is not going to be technically rapid shutdown compliant if you're putting the solar panels on a habitable building. And here is the inverter itself. Pretty decent size inverter, but one person can easily pick it up. Looks like it actually comes with the little rapid shutdown switch, which is kind of nice. Most inverters don't do that. So you won't have to spend that extra 50 or 100 bucks for a rapid shutdown switch if you're making this rapid shutdown compliant. And looks like we've got some hardware here, screws, drywall anchors, little antenna, some ferrules, some little terminal blocks. We got some knockout plugs and some knockout reducers. And we've got some kind of little button here. I would imagine, well, I'm not gonna imagine. I don't know what that button is, so let's figure that out as we go. Here you've got your equipment ground bar. Looks like right above that you got your terminal block for your AC output, L1, L2, and neutral. Over here we've got the positive and negative PV inputs and the positive and negative battery inputs. Looks like we might have a couple different forms of communication to choose from. And I'll have to dig into the instruction manual to really figure out what else we've got going on in here. So the Growatt manual is suggesting you use wire ferrules for a lot of these terminations, but my opinion is it's just not necessary. I've been doing this forever. I mean, if you can't actually get all the strands in the terminal, then yes, you should use wire ferrules. But as long as you know what you're doing, you make sure that all the strands land firmly in the terminal block. My opinion is they're just not necessary. Okay, so I made a pretty stupid mistake when pulling this wire here. I pulled this 4-wire RS485 cable between the battery and the Growatt inverter, and I came to find out that that was the wrong cable to use. You do want to use this between the inverter and the MID, but for the communications between the inverter and the battery, you want to just pull standard Cat 5 cable, because it does require a little Cat 5 crimp here on the Growatt side of things, where it plugs into the circuit board. So I'm gonna have to abandon this RS485 cable. This stuff is expensive, and unfortunately I already pulled it through the conduit. So I'm just gonna pull a Cat 5 cable external to the conduit between the battery and the inverter, and just kind of leave this capped off for now in here. Alright, so crimping your own Cat 5 cables are a really common source of human error. You just have to be so careful with these. The wires are so brittle, the connections, it's really easy to get wires crossed or get a bad crimp. So you just have to really pay attention here. When you crimp both ends, you can use a Cat 5 testing tool. In this case, we're not going to have a cable end crimped on at the LG Chem side of things, so we're not going to be able to utilize that. Try to get them as straight as possible. Check your color code a second time. Orange, white, orange, green, white, blue, blue, white. See, I've already got my blue, white, and greens mixed up here. Blue, white, green, brown, white, brown. Alright. Now you just want to do a fresh cut across the top so that they all are the exact same length. Then you take your connector with the clip facing away, slide it up in there, you press this way up in there. You want to make sure the sheathing there surpasses that little hold down clip. In this case it does. You want to double check your color coding, make sure nothing got crossed. So I feel good about that. I'm seeing that it's all these wires are stuffed up in the connector. So I'm going to go ahead and stick this in my crimper. And I'm going to crimp down. Make sure you crimp all the way. And there you go. You got a nice Cat 5 cable crimped end. Now I'm gonna just plug that into my little, I'm gonna leave a loop here. All right, next I'm gonna just leave a little loop here and terminate it right there in my battery communications. All right, so I think that's about all we've got for this video. We've got the LG Chem battery wired into our Growatt 11,400 watt inverter. We've got our DC strings wired through the disconnect and pulled into the inverter for now. We've got our Growatt SYN MID wired from our 125 amp service panel here into the grid, out from the MID into our double throw transfer switch. We've got the AC output of the Growatt inverter running over here into the Growatt MID, into the little backfed breaker here for the inverter. Really from here, we've just got to wire up the DC strings. We've got to go ahead and get our communications cable pulled and terminated between the inverter and the transfer switch. We've got a little antenna to install and just some things to button up. And then once we have our solar panels mounted on the back porch, we can go ahead and fire this thing up and test her out. If anyone is looking for any of the products used in any of these videos, go ahead down in the description below. Check out our affiliate links where you might be able to save yourself a little bit of money. If you're into DIY solar, go to www.rockybroadsolar.com and check out our free ultimate DIY guide. You can download it. It'll give you some good tips and tricks on how to choose the right equipment, how to get it installed in a safe and code compliant manner, and how to get it past that final inspection. As always, thanks so much for watching. I really appreciate each and every one of you. Until next time, take care.